Today we're going to learn how to solve geometry problems using segment addition postulate, or SAP, and midpoints. Help, help, little Timmy fell into the well. Well, at least his day will be well spent. On our agenda, we're going to learn about segment addition postulate. We're going to use it a lot this year, so we'll abbreviate it SAP. We'll do a midpoint problem, and we're going to talk about how solving problems using each. Let's get ready by grabbing your notes, pencils, and calculator. Take notes along the way and try each problem. What is a postulate? A postulate is a statement that is accepted without proof. It just makes sense. The segment addition postulate, again abbreviated SAP, states if point B is between points A and C on a segment, then AB plus BC equals AC. So remember, the word between doesn't mean that it's exactly in the middle, it's just somewhere in between. And also notice how this does not have a segment over it. None of them do. So that means the measure of, or the length of. So the length of AB plus the length of BC is going to equal the length of the whole thing. And that just makes sense. So we call it a postulate because we are adding the segments. The little segment plus the medium segment equals the whole segment. And when we're solving geometry problems, you're always going to want to draw and label a picture first. Then that will help you determine the relationship. Are things equal? Should you set them equal to each other? Do they add to 90 like complementary angles, or add to 180 like supplementary angles? Or maybe they add to something else, a total that you're given in the problem. You want to write your equation using your letters, and then you'll substitute in what you know for those letters. You'll be asked to solve for x, and usually there'll be an extension asking some more questions to solve for other segments or angles. So let's try this. We're going to draw and label. M is between R and S. So R and S, and M is somewhere in between. How are RM, MS, and RS related? Well, here's RM, here's MS. I can add those to equal the whole thing, RS, and we're going to apply the segment addition postulate. I want to write an equation using the letters. So I can say RM plus MS equals RS. That is how they are related. Now I'm given some information, and you should put that information right on your picture. So RM is 4x minus 1, RS, which is the whole thing, is 20, and MS is 9. We're going to plug that into my equation with RM, MS, and 20, and we'll solve for x. So I use the parentheses just to show the grouping for RM, but it's not a distributive property, so 4x minus 1 plus 9. I'm going to combine like terms and get 4x plus 8 equals 20. We can subtract 8 from both sides, and we get 4x to equal 12, and then divide by 4 to get x equals 3. When x equals 3, I'm then asked to solve for RM, so I want to plug it in there, and I have 4 times 3 minus 1, which is 11. So on my picture, I know that RM is 11, MS is 9, and the whole thing is 20. So it does check out because 9 plus 11 is 20. But if you notice, geometry pictures are not drawn to scale because RM looks smaller than MS. Let's try this example. I'm going to read it to you. Point B is between points A and C on a segment. CA is 20, BC is 13, and BA is 2x minus 3. Draw a labeled picture, find x and AB. I'm going to ask you to pause it and try it on your own. All right, so I'm going to draw the picture, and I have segment AC with B somewhere in between. They tell me that CA, which is the whole thing, is 20, BC is 13, and BA is 2x minus 3. That's my labeled picture. The picture is going to help me figure out my relationship. So the two smaller ones are going to add to 20. So I'm going to do 2x minus 3 plus 13 equals 20. Combine like terms on the left, so I get 2x plus 10 equals 20. And then subtract 10 from both sides. So 2x equals 10, divide by 2, and x equals 5. That's part of my answer. Remember they asked what AB is, so I have to plug that in. AB, they told me, is 2x minus 3, so that becomes 2 times 5 minus 3, which is 7. Or you could have just done 20 minus 13 and find out that that should be 7 as well. But that's a good check to plug in your x value and see if it works. Here's the labeled picture. And let's switch over to midpoints. So I've mentioned midpoints before, and the midpoint is a point that is exactly in the middle of the other 2 points. It cuts the segment into 2 congruent smaller segments. So as soon as I see that vocabulary word midpoint, I know that I can add the congruent marks, and that's going to help me figure out how to solve the problem. So in this example, we have M as the midpoint of segment RT. So I'm going to go ahead and draw that. We have segment RT, and this time M is the midpoint, so I'm going to put it right in the middle. And doesn't look like it might be in the middle, but once I put the congruent marks, I know that those are congruent, and it is in fact the midpoint. I'm going to label my picture so that RM is 4x minus 8, and RT, which is the whole thing, is 32. So they want me to find x, and they want me to find MT. Well, I don't really know what MT is right now, but if I follow my congruent marks, if RM is 4x minus 8, then this also must be 4x minus 8. And now I can apply the segment addition postulate. So I have 4x minus 8 plus another 4x minus 8 equals 32. Combine like terms on the left. Be careful, things don't cancel out. We have 4x plus 4x, which is 8x, and a negative 8 and negative 8, which is a negative 16. Equals 32. We'll add 16 to both sides. We have 8x equals 48. Divide by 8, and x equals 6. It's part of my answer, but don't stop there. I'm going to plug that in to figure out what MT is. So I have 4 times 6 minus 8, which is 24, minus 8, which is 16. And that should make sense because 16 and 16 is 32. I'm going to label it, and I have MT as 16. Here we have M is the midpoint of segment RT. I'm told that RM is 4x minus 8. The whole thing is 32, and we just did this problem. We're going to try example 4. M is the midpoint of AC. Midpoint. So I'm going to add my congruent marks. AB is 6x plus 10. BC is, I'm going to put in parentheses, 2x minus 8 plus 10x. I only put it in parentheses because my picture's a little squished. All right, why don't you pause it and try there. I'd like you to solve for x and AC. So these are not just going to have a plus sign in the middle because I don't know what they would total. I'm going to follow my congruent signs, and they're equal to each other. So I'm going to say 6x plus 10 equals 2x minus 8 plus 10x. So 6x plus 10, combining like terms on the right side, I get 12x minus 8. I'm going to subtract my 6x to get 10 equals 6x minus 8. Add 8 to both sides, and I get 18 equals 6x. Divide by 6, and I get x to be 3. I'm not finished. I need to figure out AC, which is the whole thing. So I'm going to figure out AB first. So AB equals 6 times 3 plus 10. So AB is 18 plus 10. Therefore, AB is 28. If I multiply that by 2, that's going to give me 56 for AC. And some notes to make sure you get into your notebook. The segment addition postulate, SAP, says if point B is between A and C on a segment, then the measure of AB plus the measure of BC equals the measure of AC. and the midpoint is exactly in the middle of 2 points. It creates two congruent segments. Good job.